Hello everybody, and welcome to today's XP Live webinar. My name is Nicole Highhouse, and I'm the Marketing Manager here in the XP Solutions Portland office. We are really excited about today's webinar because we're finally going to be able to present to you a unique stormwater design program that not only cuts hours from design projects, but also integrates into your CAD program. Today's presenter is Zack Sample, our Stormwater Products Manager. Zack has over 10 years civil engineering experience in site design, stormwater planning, and hydraulic analysis. Zack has performed a number of advanced water resources studies, including hydrologic and water quality system assessments, as well as 1D and 2D hydraulic river and floodplain studies. During his time with XP Solutions, Zack has helped hundreds of clients with their models, so his voice may be familiar to you. If you haven't watched our webinars before, then you probably talked to him if you called in for any kind of support. So thank you for joining us today. And Zack, you have something to talk about.
Yeah, thanks, Nicole. Thanks, everyone, for joining again. Yeah, my name is Zack Sample. And before I move on, for those who might not be familiar with, I guess, what we do in our XP Solutions as a whole, we have a long history of providing original high-performing software solutions. And as Nicole mentioned, I have been heavily involved with the technical team here at XP for a number of years, and we pride ourselves on being a wealth of knowledge and assistance for the greater engineering community. In this webinar today, we will first walk through an overview of the current stormwater design climate, then look at realistic workflow options that we face as an engineering community, wrapping up with a chance to see for yourself how easy it is to use XPDRAINAGE, the tool we'll be talking about today, and connect to your CAD program for a truly integrated design process. To start, let's look at some background on stormwater design. For perspective, while most of us here are likely heavily engaged in the stormwater aspects of development, addressing stormwater is a concern on every single development project in the U.S. So we're talking about hundreds of millions of projects per year. That, how stormwater is really always a concern, probably isn't news. That said, stormwater realistically occupies less than 20% of the entire development project workload. That is something that even myself sometimes can lose sight of. Right? There's a lot of work that goes into development projects, retrofit projects, and stormwater is really just a small portion of that. And stormwater design is fundamentally the last project component to start and the first needed to finish. So how do we dig in to this stormwater design work once the clock is running, so to speak? Well, we're going to dig in through numerous basic hand calculations, through spreadsheets and separate software tools to get the design job done. And the work is simply scattered. And each project is different, each with different amounts of data and ultimate purpose. Lastly, to push outside of what we have successfully accomplished in the past, now new green systems are absolutely required where they previously were not. From that background, let's look at the problems we're facing. Simply put, it's hard to actually perform stormwater design with so many tools and pieces involved, all separate and scattered, with such little time to do it. Confidence in the actual proposed design is jeopardized due to such basic calculations and tools being used, in particular for these new green systems. And on top of it all, engineers are tied to CAD, which is where everything except the stormwater sizing is done. It is through looking at these problems that I say XPDRAINAGE has come to you with Civil 3D CAD integration for automated stormwater designs that are quick to assemble, clear to communicate, and thoroughly reviewable. Comprehensive design automation for traditional pipe-to-pond stormwater systems is enhanced by one-click optimizing for all green runoff reduction practices. Stormwater design production is effortless and efficient with integration of XPDRAINAGE into your workflow, whatever the workflow. Now, whatever the workflow is exactly what we're going to be touching on next. From our interaction across the stormwater community, we have found that stormwater design projects follow a general workflow that moves through three primary areas: the layout, kind of the starting of the project, the sizing portion, and ultimately reporting. Projects start through three different avenues. Either there are already records or as-builts of a project on file or accessible from which to start a project. Schematic concepting can be performed in some sort of CAD tool and then referenced during the sizing and reporting portions of the project, or the third option would be the primary stormwater design tool that's being used happens to be robust enough to allow for realistic yet easy initial layout of a proposed stormwater system directly within that software. Well, that's XPDRAINAGE, right? So you can either start with as-built data, lay it out in some sort of CAD tool, or kind of jump right in with XPDRAINAGE. Yet it seems no matter how you start your project, the sizing component is somewhat universal. The three elements of volumetric or runoff reduction sizing, comprehensive protection event assessment, and pipe sizing are almost always performed, though typically in three or more different places, such as in spreadsheets, or in my case, I used to have a collection of spreadsheets within some basic hydrology tools, and perhaps, maybe, in some form of hydraulic program. So I already alluded to the fact that I personally have worked on projects as a consultant using over half a dozen different calculators or software packages, all in the same project. Just because I'm curious to see what everyone who's joined here has experience with, I have a quick poll that I'll launch that everyone can kind of jump in. So you'll see, looking at all the facets of stormwater design, starting with CAD, starting with some spreadsheet, moving into some sort of tool, and then ultimately reporting, how many different tools do you use? So I personally would check the maybe over 6, maybe over 10 is kind of what I commonly used to do. So just kind of curious. I'll share this in a second once everyone's done. Yeah, so it looks like, yeah, probably pretty similar, I guess, to my work here. I'll share this. Looks like most everyone has clicked on that. I'll share this, and you can see, certainly the vast majority of people, over 10 plus. There's 20% there. It's over 10 plus. So the bulk, looking at 4 or more different tools. So that's exactly what I faced, and everyone, even if you use maybe just a couple tools, you're going to feel that weight, that pressure that comes along with spreading that work across all these different platforms. So thanks for jumping in there and sympathizing with me. So once a storm design is created, we've done the sizing portion. So once it's created to a point that everyone's happy with, or the project budget is nearly expired, I should say, the proposed system needs to be reported across a range of formats so that someone can review and ultimately build the system. That's kind of the point of what we're doing, so someone can actually build it. This last piece in particular can be a bit of a nightmare to coordinate, especially if numerous sizing tools are used or if issues with the design are only discovered once the correctly sized pond is first compared against some sort of CAD plan. That's something that might happen very late in the game. Let's say if you have Excel and you've sized a system, that has to be translated into an area footprint. Later in the game, do we see if that will work or not? Very often, the first several times, the answer is no. The great strength of XPDRAINAGE that I will demonstrate today is not only does it excel at the automating of the stormwater sizing and assessment portion. I've shown this several times in past webinars, how strong it can be at looking at all 3 of these sizing components in concert. But with our new CAD integration updates, XPDRAINAGE can work with any starting point and any final reporting workflow that you use. So do you already have as-built information that you can start your project with? Or have you already laid out your initial stormwater concept in CAD, perhaps Civil 3D? Great. Import that into XPDRAINAGE and go from there. As I've shown previously, you can load CAD, GIS, image, or surface files directly in XPDRAINAGE and perform that layout natively within our software from the get-go. That's advantageous for a number of reasons. In particular, the ability of XPDRAINAGE to automatically set facility dimensions and elevation data automatically based on background files. There's a huge amount of time and energy that can be saved by assessing all of the design requirements all within XPDRAINAGE, especially when these designs are always shown true to calculation on the plan view. The idea of, will this work feedback is immediate, and we'll look at that in a moment in XPDRAINAGE, really what that does for us. However you start the project, XPDRAINAGE can export to CAD, GIS, land XML, pipe networks for quick updating of your CAD systems in addition to all the tabular and graphical reporting that I've previously shown. So let's jump over into the software and I will show the various integration options I've mentioned in addition to kind of a brief overview of that visualized design component and the automated sizing in XPDRAINAGE, which, as I've presented in the past couple webinars, we've already grown to know and love. So let's jump right into the software. And I'll spend a few minutes touching on kind of that, how the strength of XPDRAINAGE in that sizing component before I move into kind of those integration pieces. So this interface, this software, it's pretty intuitive. If you've ever used a Windows computer and any sort of CAD or GIS software, this is probably easy to pick up. You right-click with something on the tree view to interact, import, export, move something around. We can compare a range of different phases all at once. So you can have existing, developed, maybe a handful of mitigation scenarios, all compared side by side. If you work left to right across the ribbon on the top, you finish your project. Bring in background information, use some schematic sizing tools, import, export, pipe network, ultimately review the results. So I happen to have a site where I have some background data, CAD file, I have a surface. Just for grins, I'll show what that surface can do. I can deluge the site, kind of a concept where I can apply a little bit of rain to that surface. That's kind of a snapshot of where that water will move to, right? So in this case, all the water drains to the middle of the site. That might be the first place I'd put a pond or some sort of treatment facility. So because I have a surface, I can have that idea, that deluge, that very basic rain on grid idea. Well, I can also draw things to scale and use the elevations in the surface to kind of update my facility. So let's just say I happen to have a rain garden, a bioretention system. I'll add a facility here. Maybe that first outline perhaps wasn't done well enough. You can get as aesthetically minded as you'd like. Great, right? So here's a facility. You'll see my inflow area. Already found that, hey, let's associate to this. That's this green line. So what did I just draw? What's kind of the point of XPDRAINAGE? As we'll see in examples when we start looking at land XML pipe networks and how CAD maybe works with a lot of files, this is a really new idea, what we're doing in XPDRAINAGE. So we aren't representing a storage facility as a point, as a node. This is actually drawn how it will be built. This is the top area extent. And you'll see I have some basic dimension information here, which has already been updated for me. Because of the surface that I have, the top elevation has been sampled, has been set. It's 2 feet deep. So hey, software automatically gives me the third elevation, the base. I'll show an image of what this looks like. Top, bottom. I can tell the software to calculate the top area for me. If I give it a side slope, maybe I have to be able to mow this facility. It's kind of the easy example. And you'll see that whatever's calculated, whatever's used in the software is always locked into this plan view. That's the visualized design. If I go to size, modify, a system will immediately know if it fits on my site. And what I'll show next is, does it connect to my next facility? That's a really important one that we lose, moving between spreadsheets, moving between hydrologic tools, kind of the basics that we need to uncover. So I dropped in a rain garden, maybe I'll just drop in a pond up here, just for example's sake. Maybe I'll make this a circular facility. Okay, you get the idea, right? So here's my pond. Oh, the top outline was given to me, but now we've kind of got this snow cone idea. We have a range of sizing calculators. So I can set a side slope. Maybe I need to mow this facility as well. Right away, you'll see that it sets the stage storage curve for me. I can add in items. Again, I'm not going to spend a lot of time moving through kind of this world here in XPDRAINAGE. I want to show a lot more how it integrates outside the software, but I will at least set up. You'll see how long it takes to set up a system. I can add in some manholes, and I'll manually connect the system. So these are pipes. I have a pipe leaving my rain garden, goes through these manhole inlets, and daylights out into my pond. Great. That's nice in theory, right? That might be the schematic back of the napkin layout we have to start with, but the important item here is we can immediately see if this makes sense. We can immediately look at a long section, and based on the surface, these elevations were applied. The top of the manhole, it's 5 feet deep. We can immediately see if this daylights as it should. Now, we're starting with the existing elevation, so this probably won't be the exact final grade. These might be adjusted. So we can adjust that by bringing in a new surface. We can manually adjust these values. You can see I can directly edit from a profile. Maybe I'll manually edit the top elevation of a facility. That's what the red text is, something I manually changed. We'll see how it updates the profile. This whole world of seeing and interacting, okay, through many different forms is really the backbone of XPDRAINAGE, why it's so important. We aren't going to lose information moving between Excel and our report and CAD, right? It's all locked together. I'll even just jump to this different piece just for a second to show the sizing items, a range of different things we could do. I can size this rain garden. Perhaps I'll use runoff reduction. That's a water quality volume method. And great, it's basically a matter of what is the connected inflow volume. I'm saying there's an inch of rain on that part of the site. You could change that. Based on an inch of rain to that inflow area, here is the volume I need to hold on to. Here's the volume that I currently have. And you know what? Hey, it fails. It's not big enough. So click OK. And it will increase the size of my facility as needed. So all I need to do is click Apply Runoff Reduction, OK, and it will amplify the size of my facility. Right away, we're going to see if this works or not. I can do this for one facility. I can do this for the entire 40 pond or 40 rain garden site. So that's that kind of automatic one-click runoff reduction sizing. We can go over to a pond and use kind of some different sizing tools. So maybe I will use a different storage estimate option. I can input perhaps a desired discharge rate. Maybe this is my 100-year discharge rate off my site. And it will modify the size of my pond. I was covering it up, but it increased the size of my pond to contain that. Now I can solve the model, and we'll see kind of how this balances out. We can run a whole range of rainfall events through a whole range of phases. Well, I can jump right to my 100-year event and see that, oh, sure enough, we're just getting to the top. We only have a few % available in my total storage. All right, well, again, jump to the profile. What does that look like? You can see they're just filling up to the top. You can see this little indicator showing that the freeboard is getting met. Well, if that's a design constraint, maybe we change the model. Here the pond is filling up. So it's that quick. It's just, you know, a couple minutes of walking across these different parts of the software that would normally, you know, be days or weeks to kind of get to this back and forth process. Great. So we know that we can easily size, easily get moving through, you know, really the stormwater sizing part of this, but how do we integrate? So let's look at a couple items there. So I happen to have maybe a more complex model. So this is a system where I have, 14 different stormwater controls. You could have 40. You can see here I have this whole network laid out, pipes through this system. Now what can we do? So the first thing we're going to want to do when we're bringing something specifically into Civil 3D, now I'll mention that the same items I'm about to show really apply to you know, MicroStation. They apply to really any, you know, CAD tool. We're going to look at moving information with a land XML file. That's kind of a free open source format. That's something that very directly is used by Civil 3D. So we're going to move our pipes and our manholes back and forth with land XML. But as we'll find, that's not really good enough. And really that's been our focus. That perhaps is the extent at which a lot of software can integrate, and that's really as far as you can easily do that with Civil 3D. So we'll start right there and we'll look at the different ways we took this further. So for example, here's a site, right, very complex. And with other software, what we'll find is the items that we're very dynamically representing, we're truly showing the footprint of these facilities. Well, they might represent just with a node, right? So there's just a node that represents some sort of storage area. Same with this pond, right? This pond may normally be just a point, just a node. And you'd have pipes or connections, you know, connecting to that node. Well, first and foremost, you're probably having the wrong pipe length. Okay, that's an issue. We're truly going to show where we daylight out into a pond or into a structure. So this is the true pipe length, the channel length. This is really how big the pond's going to be. But since this isn't just a node, since this isn't just a simple item, what do we do when we transfer this into Civil 3D? So let's look. So we can start with exporting the pipe network to land XML. So easy as export. You see I can add a file, and I can choose, you know, this, you know, what version I want. 1.2 happens to be the latest version of land XML. And let me jump into CAD. So I already did this one step. It's as easy as import land XML. I can pick that network, so on and so forth. Just click OK. And, pardon me, and you'll see this network I was just looking at has been brought in. Now, I happen to also bring in kind of the outlines for the facility so you can see what they look like. But this land XML, it created a pipe network for me with manholes, but it's very limiting. Okay. So what we have done, instead of just bringing in pipes and manholes, well, here's a facility, here's a rain garden. And we truly show, if I go back to our software, we truly show this inlet location. Same with the pond down here. We are actually going to show where things daylight out. I think that's hugely important. XPDRAINAGE is showing how it will be built. Okay, let's go back into the software here. So we're going to bring these in kind of as markers into Civil 3D. So I could change the location of the inlet, you know, just to be more precise, more specific. We're transmitting that here into Civil 3D. The biggest thing I'd see in this model is Well, maybe I didn't lay out the pipe network with as much thought, perhaps, as I should have. So here is a pipe that runs really kind of through the sidewalk. Well, maybe I'll just move these manholes, maybe more on the edge of the street for an inlet, in line with the road, so on and so forth. You know, I happen to also, by default, start this model with 12-inch pipes. Okay, I can upsize those in our software automatically, but maybe there's a specific item I want to swap the part, is what it's called in Civil 3D. So I'll swap this pipe size. Great, so I've made adjustments. You can make any adjustments you want, and now I could just go to Output and Export. So great, Export land XML, and I'll write that out again. We can go back into our software. All right, so we can move back and forth between the two. So again, I will look at, here is that zone we're going to update. Now I'll go to pipe networks, I can import, and sure enough, it gives me a little, which ones were updated. So let's jump back where we just were, and we'll see how these items changed. We'll see how the manhole, all right, updated, this inlet location updated, and the pipe size updated, right? We have this 30-inch pipe. So we can move back and forth all day long with these items. Now, the issue, of course, if you go to import just a pipe network into the software, well, the idea of these ponds don't exist. They're just a point. So I happen to have changed part of the software. So if we imported this item here directly from land XML, kind of from scratch, we're automatically associating names and associating them with XPDRAINAGE objects. Well, if you just started a model from scratch, you might have, let's say, a manhole that needs to be a pond, needs to be something. Well, it's just easy as you can change a template. I can change this to be a rain garden. All right, and I can then, from that, import the outline, make a free form, however I want. And I've now converted that, what I call kind of a dumb point object into this real schematic, smart object that's updated based on our surface, so on and so forth. Okay, so that's great. You can see we can move back and forth. Civil 3D pipes, we can update items within XPDRAINAGE where they might be missing. I've shown a number of times in the past how we can right-click and we can import from CAD or GIS a range of items. What we found, talking to engineers, is kind of this next piece is, well, no matter what's done, the final grading plan, the work in CAD, is really cumbersome unless we give it some help, and that's what we did. So we can save this entire view out to CAD, so this whole plan view. So if we wanted to create the grading plan for the ponds, let's say, you can right-click and save this whole phase out to CAD. Same with these items up here, save to CAD. Let me jump into Civil 3D. That's what I've done. So it's just a matter of saving it to CAD, and I just open that CAD file. Same project, and you'll see not only do we give the connection lines, the inflow areas, and where they're connected. So you can see where things actually connect in daylight. But we also kind of gave the important information. So we are giving, even just through the basic text, top, bottom elevation, side slopes of facilities, lengths and inverts of pipes. So you can use or not use any of this information. But the point is that if you had to actually grade this pond into your proposed grading plan, well, you need to know where it is. You need to know the elevations, how deep it is. And that's the piece which is just practically really cumbersome. And so we have updated this item, so you could load this into a CAD file. So you can see here I've loaded that into my base CAD. You can see where everything's laid out. I could turn on or off the the different details. Right, so turn on the attributes for this item. Okay, maybe you like to work directly through GIS. So same thing, I happen to just drag and drop the shape files. So I exported all of my items to GIS. I can show this here, just a matter of right-clicking, and you can export those stormwater controls specifically to GIS with all of these attributes. So great, if you like to work in GIS, you can load in on top of the pipe network. You can select the pond, and you can see the feature properties. Site slope, in this case, the pond's kind of got a vertical retaining wall on the edge, depth, invert. This is what you need. This is that, final aesthetic layout that I'm talking about. Is really done, in Civil 3D to make this shape work against all the grading constraints. So on top of all these items, we can import, export from GIS, land XML files to get our pipes and our manholes. That's a bit limiting. So within XPDRAINAGE, you can change those shapes, change some of those more simple items into robust controls. Save things out to CAD. That is all on top of the really fantastic reporting that's already in XPDRAINAGE. So we might have the stormwater control report, where I can look at the percentage available volume or inflow, outflow, so on and so forth. Maybe I want to get into a lot of detail. I could show the detailed results for this individual facility. All right, so this is kind of back to that, how powerful the sizing component is. Inflow, outflow, for my large event, my different events. Just simply a time series of information. And we even take it as far as showing a 3D view of what's happening. All right, I want 8 different ways to look at this information. So I can size this, design this, look at and explain how this will work. All right, in this 3D view, we have an infiltration zone, a ponding zone. As a designer, the 3D view isn't a, print screen, you're done in your report, but it's one of the many ways you convey information. So we find out this is the right system for us. We can compare different phases. I'll go to results and phase comparison. And I can look at the results between these two phases. Just a tabular water quality event, we don't have any discharge. Well, that's desired, right? The 100-year event, perhaps we have a outflow rate 3.4 in our existing, and you know what? Hey, we're under that, right? So we're meeting our different range of events outflow rates. We can make all this comparison and then, right-click, save to CAD, export to GIS, export land XML, push that out, and any updates we make, bring them right back into the software. So there are, I'm going to call it a question I guess saw come up, the idea of does CAD, when I'm referring to CAD, integrate with MicroStation? And that's a really great question, and something that does come up from our experience, the huge number of groups we have surveyed and talked to. Civil 3D is by far the most dominant CAD tool used in the US. But all the items I just talked about, saving things out to a DWG, land XML, that's an open source format, and certainly GIS shapefiles. Those are all utilized by other software. Now, I'm not a MicroStation expert nearly as much as I am with other programs, but all of those items can be shared and updated in a range of different CAD tools and obviously GIS as well. Great, so I'll jump back just to wrap up our presentation. One thing I will say, there's some questions coming in that I'm going to talk to here in a second. One item in particular, I know that I tried to keep this presentation, try to keep it somewhat brief, and really try to focus on the myriad of different ways that we can move in and out of the software. So I didn't spend as much time as I might normally do talking specifically about really all the sizing and all the different things, kind of that automated stormwater design part of XPDRAINAGE. So certainly there's I've spoken about that in previous webinars, but I think if someone is interested, obviously, in a personalized demo, and we can kind of talk more about project specifics for you and kind of how that works. So that's one thing I will call out that I might not spend that much time on, but certainly we can do that. One that came in that wasn't addressed yet was, can XPDRAINAGE be used for flood analysis or like FEMA mapping? So I showed a 2D, rain on grid, as we might call it, map. That's really a schematic guide. That is not the kind of really robust, integrated 1D, 2D assessment that our XPSwim tool is. We aren't really doing 2D flooding in this software at all. We use that deluge option to give a good indication of where the, I'll just show that one more time, right, where the kind of on a planning level, where the water moves on our site, right? So we get an idea of these different infiltration, or these inflow areas, right? The surface-based flow which will occur. Again, if you load in a different surface, you'll kind of get different surface flooding. So that's about as far as it should be used. It's not meant for flood inundation mapping. Okay, that's really where XPSwim and XPStorm really shines. Okay. So another question looks like about the idea of importing items from Civil 3D, perhaps also how those work with Storm. I'm not really presenting a lot on XPStorm today, but I will say that the idea of land XML, importing and exporting, also exists there in XPStorm. So if you are a user of that, or if you aren't, that's also something there. This schematic nature, the way we represent, and really have kind of crafted XPDRAINAGE to look and feel and act as direct as possible for the design workflow. I mean, that's really unique to XPDRAINAGE. So I think that's all of the questions. Everything else I think has been addressed. Thank you everyone for joining. It's been my pleasure. Thanks, Nicole, for jumping in there with me. And any questions, obviously, my name is Zack Sample. Contact us. Anything you send it, as it shows here, amsales at xpsolutions.com. We will sort through any questions or comments you might have. So once again, thanks everyone for joining.